So, the topic that we are going to cover today is related to physical and chemical changes. And then later on in this lecture, we'll study about exothermic and endothermic reactions. So, firstly, let's see that what are the main differences between a physical and a chemical change, or how we can identify that whether a falling change is a physical one or a chemical one. Okay, so let's start. Let me switch on my fan over here. Okay, so firstly, we'll study side by side, like we'll be comparing both the changes. And during the understanding of this concept, I'll take example of water over here. Okay, the chemical composition of matter remains same, the first thing, and the second for the chemical change is the chemical composition of matter changes. Firstly, you need to understand that what is a chemical composition. Chemical composition is basically the constituents that make up any matter. Okay, matter can be a liquid, it can be a gas, or it can be a solid, right now. So constituents that make up a matter, for example, in case of water, it's hydrogen and oxygen that are making up the water. So the constituents of water are hydrogen and oxygen. So in case of physical composition, physical changes, the physical composition remains same. Like if I see a change that liquid water is converted into water vapors or in its gaseous state, but still you can see that hydrogen and oxygen remain consistent. This change, which is also known as evaporation, doesn't doesn't change the main constituents of water. The composition remains same. So such a change in which you can see that change is occurring, but the composition is remaining same is known as a physical change. Okay. If I move towards the chemical change, it's saying that the chemical composition of matter changes. That means, for example, if I dissolve, if I say that NaCl. If I pass electricity from NaCl, for example, in presence of electricity, it will break into Na positive and Cl negative ions. Okay, so now the chemical composition doesn't remain same. There is something new has formed, that is Na positive and Cl negative ions. Okay, so such type of change is known as a chemical change. Okay, so secondly, no new substances formed, water remains same. If it was water in the liquid state, it is also water in the gas state. So no new substances formed as a result of a physical change. But as far as the chemical change is concerned, always a new product is formed, like sodium and chlorine ions are formed over here. For example, if your magnesium reacts with oxygen and 2MgO, your magnesium oxide is formed, monoxide is formed. So it is a chemical change. A new substance is formed over here. Now it doesn't retain the properties of magnesium and oxygen. It will have its own properties. So a new substance is formed in case of a chemical change. Easy to reverse. Such changes like physical changes can easily be reversed. For example, take the example of an evaporation process in which you gain heat, in which heat is added to convert it into a gas state. Similarly, if we eliminate the heat from the gas, water, or the water vapors, it will convert back into liquid water. So such changes can be easily reversed. Okay, you don't need to apply a lot of energy or something like that to like reverse it. These changes can easily be reversed, but no, no, usually irreversible. The chemical changes are such type that they are usually irreversible, and if certain conditions are provided, then these can be reversed. Okay, but usually, for example, if burning of paper is a physical chemical change, then once the paper converts into ash, it is not possible for you to convert it into back into paper. Okay, so burning of paper is one example of a chemical change. Okay, for example, boiling of egg. If egg is boiled, then you are not able to like convert it into back into a proper egg that was not boiled. So physical chemical changes are basically irreversible at times, and sometimes they can be reversed, but it depends upon the conditions. has impact. What happens when a physical change occur? Then as a result of physical change, it might be possible that shape, size, or color may change. Okay, for example, shape, if we consider size of a liquid. For example, there is a container and 50 ml of water is in it, is in the container. Okay, so size or volume of the water will be 50. And now if it converts into a gaseous water, and I add this gaseous state of water into a 100 ml container, then it will take, because you know that the gas occupies all the space available now, so it will occupy all 100 ml. So now the volume changes from 50 to 100. So as a result of a physical change, there is possibility that a change in shape, change in size, and change in color might occur. Okay, so no production of energy as a result of a physical change. There is no energy, no sort of energy is like produced in it. Okay, for example, but in energy is produced in form of, as a result of a chemical change, there is possibility that energy in form of light, heat, or sound might be produced. For example, take example of firecrackers. Firecrackers, if you don't know, firecrackers are patakhe. Okay, whenever any firecracker explodes, then you can hear a sound. It also warms up, so you can feel heat energy as well, and sometimes light is also visible. Okay, whenever you see fireworks, you know that light is also visible. Huh? So, your as a result of that chemical reaction, three forms of energy are produced: light, heat, and sound. So, as a result of a chemical change, always, not always, but yes, at times, any sort of energy is produced. Okay, so let's move towards the example in the last point, and it is boiling, evaporation, condensation, and dissolving. These are all examples of a physical change. While as for as a chemical change is considered, then cooking of an egg, or burning of a paper, or reaction of magnesium or oxygen, or reaction of zinc with sulfur with copper to sulfate. Such type of reactions are chemical reactions. So let's do a quick review of what we have studied. Uh, I'll erase it as well. So, as far as the physical and chemical changes are considered, physical changes, the composition remains same, but in chemical changes, composition doesn't remain same. In physical changes, no new substances form, while in chemical changes, you'll see a formation of a new substance. And physical changes are not easy to reverse, while chemical changes can be reversed, or they are mostly irreversible. Similarly, there are some examples are given, and in physical changes, no production of energy is no production of energy. There is no production of energy, while in the chemical change, energy is produced in form of light, heat, sound. Okay, and boiling, evaporation, condensation, dissolving, crystallization, or what I might are all the physical changes, while the reaction between oxygen and magnesium, cooking of an egg, or burning of a paper, or rusting, the iron rusting, are all chemical changes. Okay, if I move forward now, we'll see. Let me move the slide. 1 second. So, as far as we have studied that there are chemical changes, and chemical changes are brought as a result of chemical reactions. So there are two types of chemical reactions. One is the exothermic reaction, and the second one is the endothermic reaction. So let's study. Exothermic means heat exits the reaction. Okay, exothermic reaction is such reaction in which, as a result of the reaction, heat is produced or heat is released, while endothermic means heat enters the reaction. Okay, yeah, here my heat must be written. Heat enters the reaction, or heat is absorbed. So whenever, as a result of a reaction, there is a production of heat, it will be a exothermic reaction, and if there is an absorption of heat, then it will be an endothermic reaction. So now what happens to the surrounding temperature? If a reaction is taking giving out heat, then obviously the surrounding environment of that reaction, the temperature, will see an increase in temperature. So temperature will start increasing due to the fact that as a result of the exothermic reaction, heat is being produced. Okay. While as far as the endothermic reaction is considered, as endothermic reaction involves the absorption of heat, and from where it is absorbing the heat, obviously it is absorbing the heat from the surrounding environment. So as a result of the endothermic reaction, the surrounding environment, you will see in the surrounding environment, you will see a decrease in the temperature. Okay. Then the internal energy change is less than zero. Delta E, the change in energy is less than zero in case of exothermic reactions, while in case of endothermic reaction, delta E is greater than zero. The changes in energy is greater than zero. Energy of reactants. Now, obviously, as your reactants react to produce some sort of heat energy, na, so obviously the reactants will have a high energy than products. Reactants are having the high energy, that's why they are producing energy. So reactants always have higher energy as compared to products, whereas energy of the product is less than reactants. While in the case of the endothermic reaction, because it involves the absorption of heat to produce the products, huh? So when heat is absorbed and as a result of that some product is produced, so that product will have greater heat as compared to reactant. So product will have greater heat. Okay, here are some examples like combustion reaction. As a result, for example, burning when combustion occurs. As a result, for example, in your cars, there is a process of combustion occur and you see that your car is heated up. So you can say that it's an exothermic reaction. That's why heat is being produced, which is heating up your car. And photosynthesis. In photosynthesis, leaves take in or absorb the energy from the sun to produce food. So it is an absorption process. So it will be an endothermic process. So here we have studied two types of reaction: exothermic, that is related to the exiting of heat from the reaction, and other one is the endothermic reaction that involves entering of heat in the reaction. Okay, and these are some other features that we have studied. Okay, I hope you got it, and let's move forward. It is more about chemical reactions. For example, we are going to study a reaction between magnesium and oxygen. Both react to produce what is produced as a result of this reaction is magnesium oxide, and this magnesium oxide is white ash. It is whitish in color, and as a result of that reaction, you can see heat and light being produced. So it is an exothermic reaction. When this reaction occurs, so light and heat are produced, and this production of light and heat shows that this reaction is an exothermic reaction, and this reaction is quite difficult to reverse. Like MgO doesn't break easily to reverse back to get reversed into magnesium and oxygen. Okay, and you need to balance it with two. Here two will be written like 2 mg plus O2 is equal to 2 MgO. Okay. Here is an example of the reaction of magnesium and oxygen is an example of a exothermic reaction. Next, let's move towards another reaction that is nitrogen and oxygen. As a result of nitrogen monoxide is produced, the reaction in atmosphere takes place when lightning strikes. So basically, you know that in air, both oxygen and nitrogen are present, but normally you don't see any reaction occurring over above in the above in the sky, and you see the nitrogen oxide being produced, monoxide being produced. But whenever it's lightning and temperature, I guess, goes above 2000 degrees centigrade, and whenever the lightning strikes, for example, if it is a thunderstorm or something like that, then you see flashes of lightning, where what actually is happening, that nitrogen and oxygen in the air are reacting. But now as you see that it is taking the energy from the lightning, so it is basically absorbing this energy, and as absorption of this energy shows that it is an endothermic reaction. It is an endothermic, like n2, n has to be small in a suffix, sorry, not in a suffix, in a prefix, if I'm not wrong. I don't know it is suffix or prefix. It's something like it should be written down here. Then it's 2NO. N2 plus O2 makes 2NO. So it is an endothermic reaction and only takes place when there is a supply of heat due to lightning strikes. Then there is a reaction between zinc and copper sulfate is an exothermic reaction. It is also an exothermic reaction. Zinc reacts with copper to sulfate to make zinc sulfate and copper. A dissolving of magnesium chloride in water is, and here's another example of an exothermic reaction, that whenever you dissolve magnesium chloride into water, it is a exothermic physical change. Why is it saying a physical change? Because the process of our dissolving is a physical change. Okay, but as a result of that physical change, na, heat energy is given off or produced, so it is called exothermic physical change. Okay, let's move forward, and we have our next slide. It's related to reaction pathway diagram. Okay, let me erase the already written content over here first. uh, so basically our reaction pathway diagrams are such diagrams that show the direction of the flow of reaction first, and also it shows that whether it is there is a gain or there is a loss of heat during that reaction. A diagram that shows energy levels of the reactant, and moreover, it also shows that the reactants are either at the lower or at the upper or at the higher energy level as compared to our products. A diagram that shows energy levels of the reactants and the products in a chemical reaction and shows whether the reaction is exothermic and endothermic. So the energy levels of the reactant and products are also covered in this type of in reaction pathway diagram, and whether a reaction is exothermic or endothermic, this thing is also included in these diagrams. The energy of reactant and products on the vertical axis, basically you have two axes. So in the at the vertical or y-axis, you show the energy levels of those reactants and products, and the reaction pathway is shown along the horizontal or the x-axis. Okay, so on the horizontal axis on the left sides, you have the product, you have reactants, and on the right side you have product. The energy change is indicated by an arrow. If there is an upward arrow, then it will be an endothermic reaction, and if it is a downward arrow, then it will be an exothermic reaction. Upward arrow will show that the heat being absorbed by the reactants, and exothermic a downward arrow will show that the heat being released while the formation of products. So let's see how it works. 1 minute. Okay, so here is our reaction a reaction pathway diagram. First one is for the exothermic reaction, and what is happening here is that our methane and oxygen are reacting with each other to produce carbon dioxide and water. Okay, so you first see, I'll explain you step by step. This is the side of my reactants. These are my reactants, and this is my product. These are my products. As the line here is above, for example, it's I'm just giving you an example, 100 kilojoules. So our my reactant are at 100 kilojoules, and the reactant line is above the product line, which is showing that the reactants are at the higher energy level. Okay, so then there is a downward arrow which shows that heat is exiting from the system. Okay, which shows that heat is being produced as a result of this reaction being going on. Okay, then my products are produced, and my product have the lower energy, for example at 50 kilojoules it is, so lower energy as compared to that of reactant. So this diagram easily representing that which reactant, that our reactant side is at the higher energy level, while at the product side is at the lower energy level, and heat is being exerted or giving out of the system. This is for the exothermic reaction. If I move towards the endothermic reaction, then I'll see that my reactants are at the lower energy level and my products are at the higher energy level, and the upward arrow is showing that heat is taken into the system, and as a result of that the product are produced at the higher energy level. This is at the lower energy level and these are at the higher energy level. For example, production of nitrogen monoxide involves the taking in of heat energy due to lightning strikes. So as a result of that, our product is produced. So basically, the two path way diagrams are opposite of each other, or we can say reverse of each other. Endothermic and exothermic reactions show reversed reaction path diagrams. So with that, that's all for our changes and the exothermic and endothermic reaction part. Firstly, we studied that what are the types of changes, and then we studied about exothermic and endothermic reactions. So you can go through the slides again, and if you find any problem, we'll have a time after the class to discuss. Okay, thank you so much. Just go through the topic, and I would advise you to like open your books. Similar things are written in your books, and go through that topic, and then you can have discussion with me if you find any issues. Thank you.